In this video, we're going to talk about a disk method. This is a special case of the method of cross-sectional slices when all the slices are perfectly circles. So they're circular slices. The motivation. For computing volumes of solids of revolution, all cross-sectional slices are circular disks with radius f of x. Therefore, the circular cross-sections that are perpendicular to the x-axis have radius y equals f of x. This is the radius of this cross-section. The area is going to be pi times radius squared. That's the area of a circle. That's pi times y squared, but y is a function of x, and we get pi times f of x squared. So the volume of solid of revolution using the disk method is defined as volume is integral a to b, a of x dx, where the cross-sectional areas are circles. And for that reason, we get integral a to b pi times f of x squared dx. So this is the volume formula for revolving f of x for x between a and b about the x-axis. Alright, so let's look at an example. Find the volume of the solid of revolution that is generated by revolving the function f of x equals e to the minus x from x equals 0 to x equals 1. Revolve this about the x-axis. So we draw y equals e to the minus x. That's a very easy thing to draw, easy function to draw. That's just a negative exponential that comes down. And we're revolving this about the x-axis. So you can see the solid that's generated is going to look something like this. These are the cross-sections. Of course, these cross-sections are perfect circles. And the whole solid essentially looks like this. All right, so the cross-sections perpendicular to the axis of rotation, x-axis, are circular disks with radius r equals e to the minus x. So let's define some of these variables. We have disk radius. What is the radius of the disk? Well, the radius of the disk is y. This is the radius of the disk, y. And y is equal to e to the minus x. What is the disk volume? We have a picture of one of these disks. Well, this is going to be y here, that's the radius. So if we take the cross-sectional area here, that's pi times radius squared, times the width dx, we get the volume of the disk. So the disk volume, dv, is equal to pi times radius squared, pi r squared is this area here, multiplied by dx. Multiplied by dx, and we get the volume of this disk. And this is equal to dv is pi, radius is e to the minus x, because radius is just a y quantity, squared dx. So what is the volume of the solid? The volume is going to be integral from 0 to 1 pi times radius squared. That's e to the minus x all squared. That gives us e to the minus 2x. Integrate with respect to x. This gives us the volume of the solid that's generated by revolving y equals e to the minus x from 0 to 1 about the x-axis. So this is a 3D object, and we're finding its volume. So now it's just a matter of doing the computations to find this volume. Volume is equal to pi integral from 0 to 1 e to the minus 2x dx. This is an easy integral to do. We're going to apply U substitution. We'll let u be the exponent, u equals minus 2x du. Differentiate both sides, we get minus 2 dx. And if you solve for dx, you get dx equals du divided by minus 2. So the volume will be pi times the integral of e to the minus 2x. We're reversing the chain rule, U substitution, e to the minus 2x divide by minus 2. Why do you divide by minus 2? That's coming from the U substitution technique. dx is du divided by minus 2. All right. Evaluated from 0 to 1, we now apply the fundamental theorem of calculus, and we get pi over negative 2. Put the upper limit in, we get e to the minus 2. Put the lower limit in, e to 0, that's 1. If we multiply the negative through, we're going to get pi over 2 times 1 minus e to the minus 2. This is equivalent to this expression, but it's just better to write it this way because it looks positive. I mean, they're both positive, but when a person looks at this, it kind of looks like a negative number, even though it's positive. So if you do the algebra, you can convince yourselves that these two are essentially the same. All right, so this is the volume of the solid of revolution. Let's summarize what we've done. The formula for the disk method is volume integral a to b pi times radius squared. The radius is y in this case, and y is a function of x. Pi times f of x squared dx. A is 0, the lower limit of integration. B is 1. The function f of x is equal to e to the minus x. We plug it into the formula. Volume is 0 to 1. Pi times e to the minus x all squared dx. And we evaluate this quantity, and this came out to pi over 2 times 1 minus e to the minus 2. This is the volume of the solid pictured in the last page here. There. This is the volume of this solid. And that's the disk method. All right. Thanks.